I'd like to welcome you to the third in our series of climate cafes. These lunch hour gatherings are intended to inform you of all the wonderful climate science that we have going on at the Rosenstiel School, and it exposes you to the activities of our faculty and graduate students. Today, the host department is the Marine Ecosystems and Society Department, of which I serve as interim chair. My name is David Letson, and my training is in economics, and my own personal research focuses in societal impacts of extreme weather and climate change. We will proceed today with our four panelists, a couple of our faculty members, and also a couple of doctoral students who we collaborate with. And I want to alert you that we do have a Q&A button at the bottom of your screen. Please submit your questions there. We want this to be your show and very interactive. So please send those along and we will answer them as we get them and also at the end of our presentations. So with that, I'd like to turn it over to the first member of our panel, my colleague, David Dia.
Good morning. You all hear me?
Yes.
Okay, thank you. I'm David Dia. I'm a research professor at the same department as David Letson. I work on fishery dynamics. I'm also the associate director of the Cooperative Institute of Marine and Atmospheric Sciences, which is a research institute within the University of Miami that also has as partners other universities from Florida as well as from the US Caribbean. And we do all kinds of work, including work on climate models, but as well on climate impacts. And that's what I'm going to talk to you about today. So I hope you can all see the PowerPoint. Is that good? Can you see it? Can somebody give me the thumbs up on my PowerPoint? Yeah, thank you. Okay, so we all know that fishing is a global enterprise and that you can see fishing vessels all over the ocean. These are maps of, on the left-hand side, the fishing effort, global fishing effort over a recent period where the lighter areas in the map represent more intense fishing activities. And in some of the coastal areas, you'll see color because that's even more intense, typically in the areas of the shelf. And the question is, does this fishing, is it impacting by warmings of the ocean, by climate change? The right picture is just the tint has been changed to depict warming. But if you look at the distribution of effort, something becomes pretty obvious, that the effort is more intense in the more productive areas of the oceans, and particularly intense in the areas of the continental shelves. And we know that already from where most of the catches come from. They come from the continental shelves. Now, what you should remember is that most of the growth in seafood production comes nowadays not from wild fisheries. The production from wild fisheries has been pretty stable since the middle 1980s, but it comes from aquaculture. And aquaculture is also a global enterprise. You can see here production of aquaculture by country from FAO statistics. You see that most of it comes from the Asian region, as well as the large production of salmon in the Northeast Atlantic and in the Southeast Atlantic. And aquaculture and seafood production can also be affected by climate change. In fact, we have a team of researchers at the University of Miami in our department that work on aquaculture research and that are trying to support the adaptation of aquaculture production to the challenges of climate change. I won't have time to talk about this in today's seminar, but so you know, there is an active research program at our department looking at aquaculture and the possible mitigation strategies that we have in terms of climate change impacts. But in terms of the processes that affect fish in regards to climate change. For the last 20 years, there's been a group at Erasmus and at NOAA in the lab across the street that have looked at the environmental signals that affect the distribution of pelagic fish, and collaborators with Dr. Prince at NOAA showed that oxygen levels in surface waters determine the habitat of pelagic fish, and that in the eastern part of the tropical oceans, you often have these shallow areas where oxygen is sufficient to actually support the distribution and the feeding of these fish, and these are the areas that are most productive in terms of harvest. What he showed already almost 10 years ago is that these areas are shrinking as the oceans become warmer. The area with sufficient oxygen becomes smaller, the fish becomes more dense, and therefore more likely to be caught by surface fisheries. More recent work by some of our colleagues here at Erasmus, by Dr. Liu, have looked also at another indicator rather than sea surface temperature or oxygen. They've shown that ocean heat content, which is a measure of the energy that exists in the entire water column, is actually a better explanatory variable of where these fish are migrating to. And ocean fish content, ocean heat content is one of the variables that oceanographers and meteorologists have used a long time to make predictions for weather. We are only now, biologists and ecologists are using it for understanding of impacts of climate on fish. Now, these kind of changes in water temperatures do not just affect the distribution of fish, but also the distribution of fleets. This is data from, again, the Global Fishing Watch project that monitors the activities of large fishing vessels in the global oceans. And they shown that in years where water temperatures rise, like in the case of the 2015 El Nino, the fleets move, presumably following the fish, but the fleets tended to move more towards the poles and more towards the west, escaping the areas of warmer water as a result of El Nino. So you can see that climate change and the warming of the oceans affects both the fish as well as the fleets. In fact, we've used now this knowledge on the direct impacts of climate change and ocean warming on the processes that determine the habitat of the animals to make predictions about how climate change will affect the distribution of productivity in the global oceans. These models have led to estimates that show that you will have shifts in productivity towards the poles. So the poles, the areas north and south of the equator, will show greater catch potential, and the areas around the equator will show less catch potential. Again, this is potential, this is not necessarily realized harvest. Now, these predictions are made on very simplistic models where there is a direct link between warming of the ocean and the environmental conditions that determine the distribution of fish and the distribution of productivity. But the ecosystem is not as simple as just being driven by the natural component and the environmental forcing mechanism. The ecosystem is actually also driven by what humans do to it and how humans react to the climate change challenges. So the models that I've shown you already have just looked at the direct effect of climate change on the natural system, but there's actually, in fact, all the direct effects of climate change on the humans that are doing the harvesting. I've just shown you the evidence of how fleets change, but there's a lot of other effects of climate change in terms of investment on the fleets, in terms of the perception of managers and the objectives of managers. And there's indirect effects through macroeconomics or through the human system, also on the natural system, that you have to consider in making these predictions. And that's what we've been doing in our lab at the University of Miami. In my lab, both, as well as in the lab of Dr. Beth Babcock, we've been using these simulations, which are called management strategy evaluation, where we don't just model the dynamics of the populations, but also the dynamics of the observations that we conduct on those populations, the assessment processes that we follow in the assessment of resources, as well as the management and the implementation of that management. And these simulations seek to actually look at how robust this system of management is to the challenges of the uncertainty that we have about how these systems work. So one of the challenges that we can test through this simulation system is the different climate scenarios, the uncertainty that we have about the possible impacts that climate have on every component of the system, not just the resources, but every component of the system. And these are a result of some of our colleagues in that we work in the Tuna Commission, where they looked at how the current management process performs for one of the North Atlantic populations of tuna, the albacore tuna. And they use this management strategy evaluation to evaluate, to test whether this current system is robust to the uncertainties about climate change. So I'll just go quickly about what this graph shows, but in the column you have the possible processes that may be affected by climate change. The body weight of the animals, are they going to grow faster or slower under climate change? Are they going to be more or less young animals coming into the populations? Is the variability in the number of young animals that come in greater or less in the future due to climate change? So each scenario here in each of these columns represents different possible scenarios of due to climate change. In some of the scenarios you have, for instance, a decline in the number of recruits. In other scenarios, an increase in the number of recruits. And these are backed by some of our observations about the ecology. And what each of these circles represents is the performance of each of these scenarios of the management according to each of these scenarios. And each row represents a different indicator of performance. So in the top row is whether we actually have the population exactly in the position that we wanted in terms of biomass and fishing pressure. The other rows represent whether we have the population in an undesirable state. And through these simulations, we can evaluate the robustness of the management strategy to all this uncertainty related to the effects of climate change. In this particular set of simulations, you see that these are actually rather robust. So the system of management that we have in place, which if I go back is all about this particular graph, the system of management basically adapts to the condition of the stock and decreases fishing effort when the condition of the stock is not the one that we desire. And it basically functions like a thermostat. If it is too hot, we increase the air condition. In this case, if the population is too low, we lower the catches. And these systems, according to these simulations, will be robust to all the different scenarios of climate change. With this, I wanted to just show you that we can actually simulate not just the natural system, but also other aspects of the ecosystem, and that's very important in producing our forecast. So to finish up, just some important points. The current models predict an average decline, rather small decline in global seafood production and by 2050, but for larger declines in the tropics. It's important to remember that climate change is not just going to affect productivity of resources, but also the capacity of harvesting those resources. It's also important to know that seafood production is going to be affected largely in not just in wild fisheries, but also in aquaculture, and that aquaculture is going to be particularly affected in developing countries where sea level rise may present very large challenges to those coastal aquaculture enterprise. I haven't spoken about severe impacts of climate change, such increases in storms and in flooding, but those obviously are going to cause some severe impacts on some of these harvest and aquaculture facilities. And I think, our next speaker, Katharine, will be talking about how, humans are going to be adapting to all these challenges. So in a positive note, I've shown that we do have nowadays some really interesting new monitoring and data sources for activities of fishing fleets that we can use. And I also hope that I've shown you that at Rasmus and with our colleagues of the labs across the street in NOAA, we are actually conducting research on a number of these challenges that fisheries and aquaculture are facing under climate change. With that, I'll leave it to Katharine to give her talk. Thank you very much for listening.
Thank you so much, David. And I will just start my slides, which I think should now shift. And Ori, if you could just confirm that my slides are correctly viewing right now. Yeah, great. Fabulous. My name is Katharine Mach. I'm an associate professor at the Rosenstiel School. And our group is really focused on the risks of a changing climate and how societies are managing those risks. And the reason why I'm starting with this image is in my presentation, and then you'll also hear from Nadia and Carolien and Jennifer, the core thing we are aiming towards is the interactions here. The risks that matter to people and nature are not just about the climate system, whether that's a heat wave or a flood or a fire or a drought. It is how these hazards intersect with people, societies, economies that have different levels of preparedness. And it is this set of interactions that we tackle, both in understanding the risks and supporting societal management of them. In the presentations to come, you'll hear about a big body of our work related to sea level rise and managed retreat. But to kick it off here, I'm going to start with the most controversial domain that we've been tackling, which is really the question of, does climate, in its variability, a hot year, a dry decade, or in terms of climate change writ large, affect the risk of violence, and in particular, organized armed conflict within countries? Over the last decade or so, a lot of research has amassed that suggests, maybe surprisingly, that there is a very strong linkage. If it is a hot year or a dry decade, you are more likely to see organized armed conflict, and this finding tends to hold across social scales of violence. So from domestic violence all the way through to civil war. This is unsurprisingly confusing in a way, in that the way that governments interact with groups in society is very much about the structures of our government, the structures of our economies, and the idea that climate could have some role in this landscape has, to some degree, been very controversial. So what we did about 4 years ago was set out on an assessment to make sense of this complex terrain of perhaps the bleeding edge of how climate intersects with societies. You'll hear from Carolien Kraan later, and she was really my partner in this project. And what we did was bring together leading experts from around the world who have published on both sides of this debate. Does climate lead to violence or not? And there are here people who more focus on the economic dimensions of interconnections between climate and conflict, through to people who are just straight up political scientists. And we started with 8-hour interviews called expert elicitation. It's a method from the decision sciences that are really aiming towards understanding the strengths of current knowledge as well as the limits of current knowledge. We paired together these 8-hour interviews with each person individually and then brought everyone together to really fight it out and debate the reasons for disagreement. Why is this such a controversial landscape in the space of research? What do we know about the linkages between climate and conflict, organized armed conflict within countries? And then we put that all together in an assessment. So this figure in some ways is the key breakthrough or the obvious conclusion. What we had each expert do was first indicate all drivers of armed conflict within countries, things that they, as political scientists or economists or geographers, would have on the radar. And then we had them rank all of these drivers of conflicts, from the ones that are most important for shaping the risk of conflict to the least important. We also had them rank how uncertain these different factors are. This type of method from the space of expert elicitation allows individual experts to integrate across many different lines of evidence, and so it's often a starting point. So our obvious finding here, or key breakthrough, was that climate is on the list, but look how far down climate is on the list of drivers of conflict. The basic idea here being that if it is a particularly hot year, you wouldn't expect a civil war in Norway, but in a country where the capacities of the state don't have sufficient capabilities to suppress violence, you might expect a very different outcome. You also see here that on the right-hand side of the plot, climate was also ranked the most uncertain factor. We teased this out through many different modes of analysis of how climate intersects with conflict. And it really was the case that when climate matters, it matters through its interactions with other drivers of conflict, through the way that it leads to agricultural collapse if it's a really dry and hot year, the way a disaster, a major flood, can lead to economic collapse in an area. And it is those destabilizing conditions in intersection with inequalities that exist in society that are probably the ways that this relationship manifests. We also had the experts think hard, and I'll just show one summary figure here, about the nature of this relationship in a changing climate. And the key point that I'll point out, just look at the data points above substantial increase. What this shows is that integrating across existing numeric estimates, the experts estimated that about 5% of conflict to date, 5% of conflicts have seen a role of climate in some shape or form. But this climbs up towards 26% in a world of 4 degrees Celsius increase, which is a high emissions trajectory moving forward. But uncertainties also go up, and that's largely because tipping points in the climate system, the nature of world order, are fundamental uncertainties that are really inherent to the nature of this relationship. So this is this first project, bringing together experts on the topic from around the world to say, what is the nature of climate as a risk factor for armed conflict? Where we took this work next, a few different directions, but I'll describe one of them that brought it home to the United States. We did a series of interviews across the US military, focusing on the US Department of Defense chain of command. So we did 40 interviews of active and retired military, civilian, and also military, as well as some researchers around this sphere, helping inform the nature of the evidence relevant to decision-making. We also paired these 40 interviews with an analysis of the 80 documents that have been published with attention to climate security. These are national defense, national security strategy documents. And what we found is that in terms of how the Department of Defense is prioritizing climate security concerns, it's often in the very direct linkages, things that can be managed, the nature of weather and climate-related disasters, hurricanes and floods, the way in which a changing climate shapes availability of food or water, the way it impacts installations and infrastructure, and also some of the emergent risks, for example, the geopolitical challenges associated with a rapidly changing Arctic. The risk motivation, the reason why they were concerned, range from direct threats to our bases abroad, for example, through to domestic and international concerns. And across these 40 interviews and 80 documents that we analyzed, we really saw different relationships emerging, and I'll shed light on that in the next slide. So what this shows here is perspectives of researchers as well as practitioners, people in the military, on whether the climate security threat is something that needs to be managed immediately, that's the light color here at the very bottom of each plot, or whether it's something that can be put off into the future, potentially something that will become relevant some decades down the road. And what we saw was that researchers and practitioners very much saw the climate security relationship as something that needs to be managed now. But as you work into the space of people who are actually in the military actively practicing, what they often identified was that even though personally they found it to be a threat of immediate concern most of the time, in terms of actual action, it's being pushed off. So where we've taken this work, and I'll just allude to it, and in some ways this is the perfect bridge to where Nadia and Carolien will be going in their work, is really to say, what is the nature of analysis of risks here related to climate security? For Nadia, it'll be sea level rise, and for Carolien, it's all the suite of drivers of flooding. What is the nature of our understanding, and how can it become more relevant for decision-making processes? In the military context, for example, this is about making the information regionally specific in time. It's not helpful to say, well, that decision you made a year ago could have been informed by some of our understanding of the nature of the risk. There's also the big challenge in the climate space of direct impacts versus indirect consequences. So is the base damaged, or is this something that manifests in terms of mental health impacts way down the road? Those are very different types of impacts to manage. And most critically, for knowledge of these relationships to be actionable and relevant and usable, it's got to interface with existing priorities. I really only had time to scratch the surface of our work in this area, so I'd strongly encourage you to pile up questions for all of us on the panel which will be our last focus today. And I will now switch to Nadia Seeteram.
Thank you, Katharine. That was a really fantastic presentation, and it really does lend itself really well into the work that I'm going to be presenting. So good afternoon, everyone. My name is Nadia Seeteram, and I'm a doctoral candidate at Florida International University. I am working very closely with Dr. Katharine Mach, and I'm going to share my screen now, on issues of climate migration. Everything great? Thumbs up? Perfect. As part of the Climate Risk and Preparedness Lab. And so we've been thinking very heavily about climate migration in response to sea level rise specifically, and we've been thinking more so in terms of the multiplicities of that migration, specifically what we're calling climate mobility. And if you don't know what that is yet, I promise you will by the end of this presentation. And with that, I'll just get started. So very briefly, globally, sea levels are rising at a rate of around 3.6 millimeters per year as per the last IPCC update. It's occurring. That rate is accelerating over time, and we have to adapt, because global sea level rise doesn't just bring with it permanent inundation. It increases the frequency of high tide flooding events. That's something we can see in Miami. It increases the intensity of coastal storm surges and storms, the salinization of soils, in some areas coastal erosion, all of these things. And so these events will contribute to migration and displacement over time. In fact, they already are. We have examples here in the US, in Louisiana, in Alaska, and of course, globally. But within that context, I wanted to focus in on South Florida. And so what you see here is the latest update of the Unified Sea Level Rise projections that are put forth by the Southeast Florida Regional Climate Compact. And on this note of acceleration, what I find very interesting is just the way that the projections have been updated over time. So you'll see here in that the compact had released a set of projections in 2015 and then again in 2019. And just taking a look at the projections to 2030, the end of this decade, what we can see is a 2-inch increase in that rate of rise. And that means that by the end of this decade, we could potentially see up to a foot of sea level rise. That's really quite problematic when we think about what does that mean for our county, because we have to think about both the social side in terms of vulnerabilities and then our varying levels of exposure to different hazards. And that includes, of course, the nuisance flooding, high tide flooding, sunny day flooding. We call it different things, but it's all very much the same thing. We are in the path of Atlantic hurricanes, which we're all very aware of, especially in this season. We also have a higher groundwater table as sea level rise is contributing to that, making precipitation-based flooding more likely, also something that we saw over the summer. And if these three things are interacting, then we might have compound flooding events, which are truly very scary. And of course, we have to think about the permanent inundation of areas, salinization of soils, what that does to agriculture. On the social side, in terms of vulnerability, there are about 2.8 million people living in the county. We've got about $280 to $400 billion worth of total value of exposed assets, depending on which source you reference. My sources are all there. And Miami Dade County is also just the second most unequal metropolitan area. What I mean by that is our service class represents about 47.8% of the population, and they make a median income of around $26,000 annually. It's incredibly low for a city as expensive as this one. We have a history of redlining and discriminatory housing policy that has led to the spatial distribution of Black communities being in higher elevated areas, which I'll speak on a bit further down the presentation. And 69% of our residents identify as Latinx, 53.3% of them are foreign-born. The reason I mention all of these things, this is a very distinct cultural context from a lot of the United States. And we really should be bringing that into the way we prepare for climate impacts. Specifically, I'm focused on sea level rise. And the question that I've been asking myself, that Katharine and I, we've been thinking a lot about is, well, how do we think about sea level rise induced migration within that context? We have a lot of anecdotal evidence, and we have some empirical evidence that really points to the fact that migration might only start in these sort of low-lying areas here. On an individual level, people could be internalizing that risk. They could be looking around at their nuisance flooding or roads that are flooded on a sunny day and thinking, this is probably not the best investment anymore. Developers could be thinking long-term as well. And what you might see is, or what we're beginning to see is that shift in money and that flow of people through what is now called a superior investment. These higher elevated areas here along the Atlantic coastal ridge in the mainland of Miami. There might even be sort of state-sponsored resilience investments. There are plans for transit-oriented development that, again, are thinking about the long term. Like, where would we want to invest money? We would probably want to shift that money to higher elevation. The problem here is that there are people already living there, and then returning back to this sort of legacy of racial redlining and discriminatory housing policy. There are people already living in those areas, covered up by my little text box there, but I'm speaking about Liberty City, Little Haiti, parts of Allapattah, Little Havana, I think are areas that we should have in mind when we think about the way that this flow of money and people could be raising property values, raising rents, and just allowing for the demolition of older properties for new resilience-oriented designs. This is very problematic because we don't have rent control here in the state of Florida. We have naturally occurring affordable housing. So when we take down those properties, what we essentially are doing is depleting the supply of affordable housing, and that causes displacement. And this is generally what people are sort of terming the phenomena of climate gentrification. But I think along with that is also this idea that people who were once living in a safer, higher elevated area are now having to move to a low-lying area where they could become trapped in place because they've become displaced. And so this is what we sort of mean by climate mobility. Instead of taking more of a uniform approach to migration, where we might be sort of trying to predict who is moving out of South Florida, we want to maybe start first thinking about the multiplicities of this migration within South Florida. And in this sense, migration is both an impact and a consequence of sea level rise. So as part of my dissertation, what I've been working on is gathering all this information and placing it in a framework that I'm calling the climate mobility framework. And this framework is based on our most current understanding of how people are moving in response to sea level rise. And essentially what I've done is the framework is organizing people in response to their, organizing people based on their exposure to sea level rise sea level rise and its various hazards. So that exposure risk category here, and then social economic vulnerability on this side. That's what SEV stands for. And so just to sort of walk through this, if you are of a low sea level rise exposure risk and you are lower on the socioeconomic vulnerability scale, well, you might be stable. You don't really necessarily need to move in the near term. And these are, for example, I'm talking about areas like Coconut Grove, Coral Gables. On the other side of that risk spectrum, if you are of a high exposure to sea level rise risk, but of low socioeconomic vulnerability, this is a lot of the county, you're most likely to maybe migrate, either individually, you can sort of assess that risk on your own and decide to sort of leave, but there also is a growing body of research, also research that is being conducted as part of Dr. Mach's work. You'll be hearing a little bit about this from Carolien as well, that state-sponsored buyout programs also might be sort of historically at least moving or at least favor those areas that have higher capacities, wealthier areas that are able to sort of initiate and administer those buyouts. Moving towards the other side of this framework, the high socioeconomic vulnerability scale, if you are of a higher socioeconomic vulnerability, and again, a lower sea level rise risk, you might be most likely to be displaced. That sort of builds on the body of literature by Jessica Keenan, again, sort of talking about that climate gentrification phenomena. And finally, if you are of a high sea level rise risk and a high socioeconomic vulnerability, well, then you have a high likelihood of being trapped in place because you don't have the financial assets to really mitigate risk on your own, and you are in a sort of high risk geography. Now, moving that from a conceptual framework and applying that to Miami-Dade County, this is part of my preliminary analysis, and so this is just a very basic understanding of what we're doing here. I've created a socioeconomic vulnerability index that is a composite-based index that only considers indicators of race, total population, median income, and age. These are very prominent indicators in the vulnerability literature. So we just started there just to see, how these indicators are interacting. So I computed that index, and then I divided it based on quartiles. So the way to read this chart is if your area that you are living in falls within is either less than or greater than the first quartile on my socioeconomic vulnerability index scale, then I've considered you of low socioeconomic vulnerability, and that is associated with the migrating and stable typologies in the mobility framework. If you are somewhere in between the first and third quartile, you are somewhat moderately vulnerable. And if you are either equal to or beyond the third quartile, then I've considered you to be of a high socioeconomic vulnerability, and that corresponds to the trapped and displaced typologies. Now, the way to read the sea level rise component and the risk component here, I've assessed this through a bathtub model approach. This is, again, very preliminary, so we're just trying to see how these indicators are relating to one another. What I've done is I've taken the NOAA high projection scenario from the unified sea level rise projections. And what it says is, for example, by 2060, in this projection scenario, if you are occupying an area that is less than or equal to 3 feet of sea level rise, you might be facing permanent inundation. So this is just about permanent inundation. It doesn't include those other hazards that I mentioned. And so again, another example here, beyond 2100 plus, areas that are greater than or equal to 9 feet of sea level rise under that same NOAA sea level rise projection would be considered stable and still not at risk for inundation. And so what that looks like is this. This map to my left is basically the way this has been applied at the census tract level. So it is very aggregated. We can't really see distinctions within neighborhoods, but for the most part, the colors here match the colors in the table. And what we can see is it does sort of map on to some of the hypotheses we have formed initially. Areas that are displaced, that sort of lighter red, do sort of capture areas in Overtown, Little Haiti, and Liberty City. Areas that we had predicted to, house trapped populations do sort of encompass areas of Homestead and South Miami. Areas that are stable are in green. It just sort of map onto areas in Coral Gables, Pinecrest, and such. And areas that are migrating do sort of map onto areas across Miami Beach as well. Again, this is aggregated, so we have not seen that sort of finer resolution. That will be the next set of our work. But what this breaks down to in terms of population is about 47.3% of the total population of the county can be classified into one of the mobility typologies. 52% of the population does not, because that framework is really good at pulling out the extremes here. But people who sort of fall either into a moderate risk of sea level rise risk or a moderately on the vulnerability scale don't really match on to the typologies as well. But the preliminary results do indicate that the Black population represents about 17.7% of the total population of Miami-Dade County, but over half of that population is categorized into either a displaced or a trapped typology that is very reflective of the historic racial inequality that exists in Miami, and it indicates this could be a dominant force in perpetuating climate injustice if public interventions really fail to mitigate that outcome. Only 11% of the total population of Miami-Dade County falls into a stable typology. The non-Latinx white population represents about 13% of the total population of Miami-Dade County, but accounts for 21.2% of the population in the stable typology. And I do have a more a breakdown of that based on these three groups, but I think I might be out of time, so I might have to just pass to Carolyn, and I'll take your questions at the end.
Hi everyone, my name is Carolien Kraan. I am a PhD student at the Abess Center for Ecosystem Science and Policy at the University of Miami, and I'm also part of the Rosenstiel School's climate risk and preparedness lab group. So I am interested in my dissertation research in how we can avoid flooding. Usually the rhetoric about flooding is very much about fighting the water, building higher seawalls, building higher levees in order to keep the water out. But there's also another solution. So this is a graph that Nadia has also just shown to you. If we look into the future, the changing climate will bring with it probably a higher hazard of flooding. This is a map or a graph showing sea level rise projections for Florida specifically, but along all of the US coast, we expect sea levels to rise. This causes not only inundation in certain low-lying areas, such as particularly here in South Florida, but also higher risk of flooding, more erosion, and also as weather patterns are changing, we expect more flood hazards in inland areas as well. Generally speaking, there are about 3 types of measures we can take in order to prevent flood damages and flood risks to people. On the one hand, there's protection. We can build those levees and those seawalls in order to make sure that the floodwaters stay out of our neighborhoods and that we all stay dry and safe. We can also accommodate, which means that we change our infrastructure in order to be able to deal with the floodwaters coming into our neighborhoods. So here in this graph, you can see that these houses are built on stilts so that the water can come and go without the houses actually being flooded. Other examples here would be raising the electricity in your house to higher levels so that even if your house does flood, the electricity doesn't cut out and there's less damage to repair afterwards. And then the last type of actions you can take is retreat, which is just the technical term for moving people and property away from high flood risk areas. So one way in which we do this retreat or manage retreat is by voluntary property buyouts. This means that the government or people agree to sell their home to the government. Government funding is used in order to allow those people to get their investment back on their property and move away to a less flood-prone area. And then those places are turned into open space. And so here you can see an example of a neighborhood where buyouts have taken place. You can see on the left-hand side, the creek in the top right-hand corner, and then a neighborhood full of houses. And on the right-hand side, you can see the same creek, but a lot fewer houses in that neighborhood. So now next time this creek will flood, we will have a lot less damage and a lot less flood victims because those people that used to live there now live in safer places. On the other hand, those buyout programs are usually voluntary. So the homeowner has to agree to sell their property to the government, and not all homeowners agree to do this, either because they don't agree with the amount that's offered for it, or they prefer to stay, they don't feel like they're in an unsafe place. And so what happens is very clear on this image. You can see that some of the houses remain, and at this point in time, local jurisdictions actually have a legal requirement to keep on maintaining the roads and to keep on maintaining services there, such as sewage and electricity, but also mail delivery services. And so this might not make managed retreat through voluntary property buyouts always very efficient. Now this land is just grassland that is being mowed, but it's not turned into a high utility, such as restored wetlands or maybe a park or even athletic facilities, which is something you could do if all the houses were gone. But if we zoom out from this neighborhood level to a nationwide level, this is the map that we see. So even though in most instances where we have flood risk, we deal with this flood risk more through protection and through accommodation, managed retreat is actually not very uncommon. Here you can see a map with the dots indicating all the counties where buyouts have taken place. In total, about 1 in every 3 counties in the United States has experience with buyouts, though usually this is a fairly small scale with only about 1 to 10 properties being bought out. Only in about 100 counties all across the nation, more than 100 buyouts. So more on a neighborhood level, we see that buyouts have taken place. FEMA has, the Federal Emergency Management Agency, has usually funded those buyouts and done this in post-disaster context. So as FEMA comes in after disasters and helps with the cleanup, they also usually make money available to the states in order to help do flood prevention activities, such as buyouts, but not just limited to buyouts. So now in order to understand why buyouts take place in those locations, let me take you to a map of flood-related property damage. So in this map, we can see by color since 1989, so approximately the start of when FEMA started doing those property buyouts, where flood damages have occurred. As a little factoid, because I'm assuming that most of you that are listening right now are in the Miami area, Miami Dade County is actually the county with the highest flood related property damages in this time frame. And I'm telling you this not just to let you know that Miami has a lot of flooding, as you might probably be aware of, but also to let you know that high flood related damages are not just a product of how often it floods or how severe those floods are, but also of the property values that are being flooded. Now, if we compare those two maps, we can see that most places where buyouts have taken place have pretty high flood damages. But we also see places where flood damages are pretty high, and we actually don't see a lot of buyouts, most notably also here in South Florida. Now we wanted to learn more about not just where buyouts take place in terms of where the flood risk is, but also why buyouts are more likely to take place in certain areas than in other areas. And in order to be able to look into this, I'd first have to explain to you a little about how buyouts are funded. So usually money for buyouts is made available at the federal level through FEMA grant programs. But FEMA or the federal government doesn't actually determine themselves where those buyouts take place. After a disaster strikes, they make money available to the state. And then within that state, county and city governments can apply for that funding if they fill out proposals and if they have plans in order to be able to use this funding for buyouts or for other measures. And so the role of the county and the city governments is really key here. They are the ones that apply for the funding, they organize and administer a complex project such as the buyout, and they also usually become the owners of the property after the homeowners have sold their property to them. Again, I want to also stress to you that the property owner is a voluntary participant in buyouts, and so people can be evicted or have their property condemned through these programs. People have to be willing sellers to the city and county government. Because of the important role of city and county governments, we wanted to look into this in more detail, and we actually found something that was quite surprising. I told you before about the different measures that we can use: protection, accommodation, and retreat. And one might expect that protection might be something that we do more in places that have high population density and high property values, because it's worth protecting all that property in a small amount of space. And that it might actually be more likely that we see retreat in places that are more rural, where it might be financially prohibitively expensive to build levees and seawalls in order to protect only few people. However, what we found is actually the opposite. We found that counties where buyouts were taking place, on average, were a little bit wealthier than counties where buyout did not take place. You can see this by the fact that the average of counties with buyouts, the orange vertical line, is more to the right as compared to the average of counties without buyouts. We also found that those counties are more urban and more likely to have higher populations and higher population densities. We think that this has to do with capacity of those counties, that those counties that are bigger and wealthier and have people that are more highly educated probably are more likely to have people on staff that can do these kinds of projects, and maybe also more political willingness to do them. On the other hand, when we looked into those counties where to the neighborhoods where those buyouts then took place, so now we look into all the counties where buyouts have taken place, and we look at the specific neighborhoods proxied by the zip codes of where those buyouts have taken place, we see the opposite effect. We actually see that buyouts take place in the neighborhoods that have slightly lower incomes and that are also more vulnerable by a number of other measures, such as those neighborhoods have more racial diversity and have lower levels of education. Since studies of buyouts have shown that there are some unintended consequences of buyouts that might negatively affect people who participate in them, we're a little bit worried about this. At the same time, it is also something that seems sense, that we help use government tax money in order to protect the people or help the people that might be most vulnerable. But we really need more information about how buyouts are affecting households that participate in the buyout program in order to learn more about whether we need to be worried about these trends or not. And so in my current research, I actually ask the question of where buyout households move to. So I do this by taking addresses where buyouts have taken place and looking into publicly available data about property sale transactions in order to be able to find who was there in those properties before. And then I go back into the property sale information and see where those people moved to. Using this data, I can answer questions such as whether people actually moved from less flood-prone areas to more flood-prone areas, whether they were able to move to a neighborhood that has similar characteristics, for example, similar types of schools or similar crime rates, or whether people were not able to move, and whether people were able to stay locally or have to move very far away. And so I study past experience with retreat in order to sort of provide lessons for future managed retreat. We've already spoken about how the future climate is changing and flood risk is increasing. And so we can learn things about the scale and location where buyouts have taken place in the past. We can learn about how to do managed retreat and buyouts in order to make sure that inequalities are not exacerbated, but instead reduced, and also how to make buyouts better for people who participate them and have more positive outcomes. And so with that, if you have any questions, please put them in the Q&A box, and I'll hand it over to my colleague Jennifer, who will moderate the Q&A session. Thank you so much.
Great, thank you, Caroline, and a huge thank you to all of our speakers for those fabulous presentations. I am Jennifer Neiman, a research analyst in the Climate Risks and Preparedness Lab group, and I'll be passing along the great questions that came in throughout the presentation to our speakers. So to start with the first presenter, David, we have a couple questions for you. And I believe you can also see the Q&A questions, but I'll read them for our audience. The first is asking you to talk more about the new monitoring data sources that you mentioned in your talk.
Thank you, Jennifer. I guess you can hear me. Yes, thanks for the question. And the data sources that I was referring to come from two sides. One is new data sources that allow us to understand more the changes in the fishing operations, and I'm referring to, for instance, the Global Fishing Watch initiative that compiles data from the satellite monitors that large vessels have to have for safety at sea reasons, and that is now being, through artificial intelligence, translated into indicators of fishing effort at the global level. So that's one of the sources that I mentioned in the talk. The other, it relates more to what the resources are doing, and this largely comes from two sources. One, remote sensing products that help us with changes in productivity, and the second, data derived from tags that animals carry, and that provide information through satellites on the locations of these animals. So those are the two data sources that I mentioned in the talk. I would add that fishermen increasingly are willing to provide information that they are collecting in the fishing operations and that are useful for understanding some of these impacts. An example would be the monitoring sensors that they put on the fish aggregating devices on the open ocean that help them locate the schools of tuna and large fish, and that they are providing to scientists and allow us to better estimate the abundance of animals in the ocean. But that's a great question.
Great, thank you for answering that. I will ask you one more question, David, and then go back to you depending on the time that we have remaining.
Okay.
I'll ask you the one that came in first, asking specifically what will happen to nearshore fisheries, which is prevalent in developing nations for fish protein rather than the large-scale fisheries. They're asking, will this same tropical versus other regions differences occur?
Yes, so unfortunately, all the modeling, as well as some of the initial evidence that is coming up as a result of the impact of climate change, point out that the highest vulnerability occurs in these developing nations in the tropical areas, both from the point of view of threats to the aquaculture production, as well as the coastal fisheries. In both cases, many of the resources that they depend on are either migrating poleward and because of the warming of the ocean, or in the cases of the aquaculture facilities, are being threatened by flooding and by the lack of productivity in the coastal areas. So it is true that one of the biggest threats of climate change that is probably going to actually affect the most vulnerable communities that in the developing countries that depend not only from their income on seafood production, but also on the protein from seafood production.
Perfect, thank you. I think time will allow, I'm just gonna ask you your last question
an audience member is asking, if species are expected to migrate poleward, what does the current science say about the possibility for invasions at the equator? And what work needs to be done to get a better understanding of this?
I don't know that there is a lot of science in terms of related to the new invasions of linked to climate change in the tropical or equatorial areas, except for that relates to pathogens. I think there is quite a bit of evidence about pathogens being more prevalent and more likely to infect animals because of warming, but not so much in terms of invasive species. I cannot answer in regards to invasive species.
Thank you. Okay, I have a couple questions for Nadia. First, I believe is the clarification on your slide 5, the time frame for the sea level rise induced migration. What is the time frame?
Right. So I think that is really sort of describing a combination of anecdotal evidence that we are currently sort of seeing at the moment, and also what we know from literature and sort of predicting out what those climate mobilities will be like. So the time frame there, it's more conceptual. I didn't necessarily have a time frame in mind. It's more to describe what the framework is built on.
Okay, perfect. And there's another question for you, Nadia. There's an audience member that's interested in knowing how you made the distinction between the trapped populations and the displaced populations. And I guess they made the distinction that the displacement would depend on some geographic variables. So just how did you make those distinctions?
Right. And so I think here that it is based on the sort of geographic element of elevation. That's sort of what I use as a proxy for sea level rise risk. And so what the literature is sort of saying is that, at least from sort of what we can pull from the Jesse Keenan article, is that the way that displacement sort of is different is that there are people sort of existing in an area, and then resilience investment sort of might flow to that area. People on an individual level might be wanting to move to what they call a superior investment area or a lower risk geography, and that in itself might fuel a trend that is displacing people. The trap typology is actually very interesting because there's quite a bit of work. There can either be people already existing in an area that is of a higher risk, and there are people of a high social economic vulnerability in that area. But when sort of combined with this climate gentrification trend, the idea is that people who are displaced might then have to move to those higher risk areas because they are more affordable. And so it's sort of two-pronged in that sense. And all of the sources that I've placed in the framework, you know, I'm still constantly updating that framework and working through the literature as I find it. But essentially the framework is a compilation of different sources of literature that indicate these could be trends in the future.
Perfect, thank you. We have one question on a slide that both Nadia and Caroline, you used, the projections for sea level rise coming from the Southeast Florida Regional Compact. Somebody just wants to confirm that they did see on those projections a sea level increase from 10 to 21 inches by 2040 based on those various projections. Just a confirmation that that's what that slide was showing. Mm-hmm. The next question is asking about whether these projections assume a relatively stable Miami-Dade economy, and approximately 20% of Miami-Dade is under 12 inches of elevation. And so once we have 12 to 18 inches of inundation, it seems that banks may stop lending, which would create an unstable, potentially devastating blow to the local economy, meaning the housing market. And then not to mention an exodus of the displaced people who make up an important part of the economy. And this attendee is wondering, how is this addressed in the research?
Is that, I guess that's for me potentially, or?
Yes.
Yeah, okay. So one thing that I want to sort of make clear is that this framework does not necessarily have explanatory power. This is more of a conceptual framework that we have, again, organized literature that we are seeing indicates these sort of trends based on exposure risk, based on vulnerability. And so we are not sort of predicting outwards. It is more of a framework to sort of understand as the regional economy sort of stands, and vulnerability, as you notice, doesn't change here. We are assuming static vulnerability based on current data. Sea level rise risk changes over time because we can kind of understand. But the point is that we can kind of understand through the projections the way that it might change. But projecting out population change, the way that the housing market might respond, that isn't necessarily the goal of this particular research. We are just trying to show, if everything were to sort of stand as it is, vulnerability not changing, the risk, knowing what the risk of sea level rise will be in the future, this is the way that we can kind of organize people in terms of who might be migrating and what that typology of migration represents.
Jennifer, may I chime in here? Since my background is in economics. John Wall, I think your question is right on the mark, even if it isn't directly addressed by our panelists. Miami is going to be here a while, but it certainly is going to change. The cost of living you would expect to go up. We have to pay for all these protections that we're talking about. And yeah, when financial intermediaries get tired of insuring us and lending to us, then you have to find somebody who can pay cash for your house. And you would expect that that would really change our demographics. Who's going to take our service jobs in that point? How far are they going to have to travel? Yeah, I just wanted to say something about the importance of your question. We are thinking about that one, even if it isn't on the panel today.
Perfect. And I think, Katharine, could we get your viewpoint on that question as well?
Great, yeah, and I think there are a whole cluster of questions here that are getting at this fact that the future is deeply uncertain and climate sure doesn't make it more certain. So I'd like to address that broadly, and then I'm going to do a pass to Carolien on some of the specific ones related to buyouts and kind of how to make them more equitable in the future since you're working on that so deeply. So exactly as Nadia described and Dave described, and many of the questions have gotten at, some of the impacts of climate change that will matter most and drive change in societies and economies, we don't know exactly when they will occur, where they will occur, but we have a lot of understanding of what the risks look like. Whether it's floods or fires in the US, we are already seeing nonlinear changes where our existing financial capacities, the bond ratings that municipal governments rely upon, the availability of insurance is changing. And I think as many of the questions are getting at, those are likely to be points of pain that simply are outside of the bounds of our historical experience, and we don't really know what they look like. So a lot of the work that we're doing in our group, very much Nadia's work, Carolien's work, and a whole suite of collaborations, is basically grappling with the fact that these uncertainties in the future about the biggest risks are going to have features that we will never be able to say exactly when until it has happened. So what that means is that we need to think about adaptive pathways that keep societies safe and that can be nimble and adaptive through time. Part of that is bringing together, even though we don't have perfect understanding of future economies by definition. And there are a lot of different ways that we can think about the core decision points when goals will no longer hold, such as ability to live safely in a given location or to ride your bike to work. And those are the types of things we're putting together in adaptive pathways context. And then to the whole suite of questions getting at the role of managed retreat, I'll just briefly mention that we're working really hard on the ethics and equity. Why buyouts happen? I think part of the challenge of buyouts is that they've been looked at as a tool for flood risk when really they're as much about housing policy, and we need to be bringing together radically different domains of the human experience to do climate response as well. And also what we're trying to look at is where have places developed well? We mostly put houses in the floodplain, but there are actually a lot of lessons to be derived from the locations that have done smart development in the first place. And I'll just pass to Carolien. So many of these buyouts questions pick up on those themes specifically.
Sure, yeah, one of the questions about buyouts that came in was about the best policy for equitable buyouts. And so as I as I mentioned in my research, one of the things that I'm focused on is on making those buyout policies more equitable, making sure that people have equal access to those policies, and also making sure that the costs and the benefits of those policies are distributed equally in society and don't exacerbate existing inequalities. And so there's a lot about buyouts that, even though they've been taking place at this nationwide scale and quite a large scale, more than 40,000 properties have been bought out, there's actually a lot about buyouts that we don't really know. We don't really know how different buyout programs, because of the administration and the organization of buyouts usually happens at this local scale. There's so many very differences between those local scales. There's difference in how people are compensated for their home, how people are treated, how fast buyout processes are. And so there's a lot that we don't really know about how it influences people's outcomes and people's experiences with the buyouts. But there are some best practices that we know that we have uncovered from case studies into buyouts. And so one of these, for example, is making sure that you create the buyout program in collaboration with the residents, making sure that the residents actually have a say in where the buyouts occur, what happens with the land after the buyouts, that they're being kept in the loop about decisions about buyouts, that they understand why buyouts are offered in one location and maybe not in another location. And also important for equitable buyout policies is, for example, the compensation schemes. The way buyouts are funded right now through FEMA is usually people are able to get the pre-disaster value for their home. So basically, if the home weren't damaged, what is the market value for their home is what they would receive for it. But that doesn't always mean that people get enough money actually to allow them to live in a comparable place nearby. For example, buyouts happened on Staten Island in New York after Hurricane Sandy in a neighborhood that had relatively low housing prices compared to the rest of New York City. And so some people were able to find a property nearby in the same neighborhood, but also a lot of people had to move across the Hudson River to New Jersey in order to be able to find a home they could actually pay for. And I think this also teams in with a comment that I received from someone else about the costs of buyout to local institutions and to local governments. Because buyouts, even though they have great pros, they reduce risk permanently by moving people out of the floodplain. They can reduce damage costs and repair costs that local governments have to make. Buyouts also bring costs for local governments. This person made a remark about how tax revenues will decrease, which is true. If you remove properties from a jurisdiction, those properties will no longer be taxable, and so revenues will decrease. And some jurisdictions will be able to build other housing stock within their jurisdiction, but in safer locations. But in other cases, people might actually move to different jurisdictions, and there really is this loss of tax value. And then there's also, because local governments usually become the caretaker and the owner of the land after buyouts, they also have to fund the maintenance of this land or whatever new purpose this land has to get. And so there must be funding for that. And there's also an equity component there, because richer and especially more dense neighborhoods might want to do a buyout because they're able to turn a buyout plot into a park, and they value this park in their neighborhood. But this might not be something that is achievable for neighborhoods or for local governments that actually have much lower incomes and face much more stringent budgets.
Thank you, Caroline. We have one more question for Nadia before we run out of time. And one attendee wants to know, what is the extent of transferability or applicability for the climate mobility framework that you presented in other contexts? Or are you considering other factors that would shape this?
Yes, so we are thinking very hard about the transferability of this framework. It is specifically meant to address field voids, risk, and then vulnerability. And so the way that the risk component of this work can be measured, I think, would differ based on location. But we are thinking that this framework pretty much only works well in developing economies where there are strong property rights. And so a future potential research area is, what does that framework look like where those rights don't exist? Katharine, would you want to say anything more on that?
Yeah, no, I think just the fun point to connect to is that what Nadia really is doing here is kind of best practice in the space of how indicators of vulnerability can and should inform risk screening for choices made. And oftentimes what exists so far in the United States is either nationwide metrics of social vulnerability or statewide metrics. But when we think about the unique demographics and history of a place like Miami, what Nadia is doing is taking something that could apply in many places with property rights, as she described, but really saying what matters here in particular and what are choices that can be iteratively queried in thinking about the implications of different response strategies. So in a way, I think Nadia is taking global practices, going local, and by going local, that then becomes something that can be replicated in similar ways in many other places facing substantial sea level rise risks.
Perfect, wonderful. Thank you everyone so much. Unfortunately, we are out of time today. So if there were any questions that were not answered, so I believe we did answer the majority of our questions. So thank you everyone for joining us today for this third Climate Cafe and for submitting those wonderful questions. Just a reminder, all of our Climate Cafes are recorded and will be posted on our YouTube channel, at Miami RSMAS. So thank you everyone so much for attending. Thank you again to our speakers. Have a wonderful afternoon, everyone.
Thank you. Thank you.